So today we're going to learn about the factored form of a quadratic function, and we're going to come back to this question that's here on your screen tomorrow in class at the beginning of class. And it is comparing three different representations. But what I want to talk to you about right now is just what these different forms are. So I want to remind you that vertex form you already know. And vertex form is going to be y equals ax minus h squared plus k, where vertex form is going to give you the vertex. That's like the number one things that it tells you. It also pretty quickly identifies the axis of symmetry. Okay, standard form is y equals ax squared plus bx plus c. And standard form more readily gives you the y-intercept. And factored form, the one we're going to learn about today, is y equals a x minus. This next one, the letters don't really mean anything in particular, so I'm going to call these R1 and x minus R2, where R are going to be the roots. So factored form is going to show it's the roots or the zeros, those mean the same thing, for the parabola. One last thing to add, A in all of these shows vertical stretches or compressions and any reflections that may be occurring, so whether or not the parabola opens up or down. So let's remind ourselves how to factor. If you remember from your warm-up yesterday, you did the X game, so we're going to do that here. In this factoring, this is a trinomial because it has three terms. And so for trinomial factoring, we are going to do X game. We're looking for two numbers that multiply to give us our AC values. So this is our multiply. And we're looking for two numbers that are going to add to give us the middle number. So I need two numbers that multiply to give me 12, add to give me 7. In this instance, those numbers are 3 and 4, which is going to make my factored form of this expression x plus 3 and x plus 4. And that is how we factor. All right, now the question is going to come, well, what if there's a number in the front? And so I like to call this bottoms up. There are other methods, but I think this one generally works the best for most people. So I'm going to multiply a times c. It's going to make my top number -6, and my bottom number is going to be -5. So I'm looking for two numbers that meet this criteria. Those two numbers are -6 and +1. And if this were like the first one, I would just write my factors as x minus 6 and x plus 1. But here's the thing. I just multiplied by this 2. And I can't just multiply because I want to. I've got to undo that, so I'm going to divide by 2. In one of these factors on the left, -6 divides by 2, so that's going to give me x minus 3. But on the right, it doesn't divide, so that I need to bring the bottom back up to the front. So then that is going to leave this second factor as 2x plus 1. And there's my factored form. As a reminder, factoring is just basically unmultiplying a polynomial. So if you were to redistribute on this problem, you would get back to the original expression. So for this example, what I would like for you to do is write down this equation and this graph that is given. And specifically, your graph can be a rough sketch, but you need to note where these x-intercepts are at -4 and at 2. So if I factor this, I need to come up with two numbers, multiply to give me -8, add to give me 2. Those numbers are going to be +4 and -2. So my factored form of this equation is y equals x plus 4 and x minus 2. And what we want to notice here is how these factors, x plus 4, relates to a root of -4, and x minus 2 relates to a root of +2. So one kind of quick little cheat that you can remember and pull back from is remember that inside is opposite. So those were inside parentheses, so their solutions are going to be opposite. But let me show you a better example or explanation of where that's coming from. It's coming from something called the zero product property. And so the zero product property, you should write this down, states that if two numbers multiply, or any collection of numbers really, multiply to give you 0, then either one of them has to be 0 or both of them. So in this example above, either x plus 4 has to equal 0 if we're on the x-axis, or x minus 2 has to equal 0. Well, when I solve those, this gives me a solution of -4 when I moved across the equal sign, and the other one gives me a solution of 2. So let's look at how this comes into play when we actually solve an equation. So for the zero product property to be true, we need to start by having the equation equal 0 first. So I'm going to rearrange this equation and subtract 42 over. And now I can factor this, two numbers that multiply to give me -42 and add to give me 1. That's a 1 right there in the middle, by the way, if you don't see it. Those numbers are 7 and -6. So I've got the factors x plus 7 and x minus 6. And now, because my equation equals 0, I can give myself a few cases. Either x plus 7 equals 0, meaning x equals -7, or x minus 6 equals 0, meaning that x equals +6. And the last thing I want you to make a note of, notice that on these we're getting 2 answers. Kind of the cheat for that is the fact that this says x squared. Because it says x squared at the top, that means that we should be getting 2 different answers in the end. All right, so in this example, if you will pause and kind of read the word problem, you notice that this gives us an equation, and this is asking when will the ball hit the ground. So we kind of looked at problems like this yesterday. We've got a ball that's going up, and if we look at the graph of it, we're looking for when it hits the ground, which means we're looking for when the y is 0. So we're going to start by setting our equation equal to 0. So -16 t squared plus 32t plus 48 equals 0. Now, if this had said to round, I think we talked about this the other day, if this had said to round, then maybe we would need to consider using our calculators. But we're going to try this with factoring and see if we can figure this out. So the first thing that we need to do anytime we see something with factoring is divide by a GCF. So in this case, I see that all of these are divisible by -16, which is going to give me t squared plus 2t, not plus, minus 3 equals 0. And this GCF is going to come to the front even though it's not helping me solve. All right, now I'm going to, again, do my trinomial factoring. 2 numbers that multiply to give me -3, add to give me -2. Those numbers are -3 and 1, so t minus 3 and t plus 1. Again, this equals 0, so I'm going to set my different pieces equal to 0. Now notice this time there are 3 factors in this problem. -16 already doesn't equal 0. So -16, this right here gives me no specific solution. So it's kind of a dead end. The other 2, however, I can solve to equal 0. So t minus 3 equals 0, or t equals 3. And t plus 1 equals 0, or t equals -1. Now, in the context of this problem, we're talking about a golf ball, and these t's represent time. Well, there's no way the golf ball could be at a time of -1. This doesn't make any sense. So the only solution here would be that the golf ball would hit the ground at 3 seconds. So I would at least get part of that explanation in your notes. Okay, so in this example, this is actually the same factoring as the previous example. So I'm going to go ahead and write out my factored form from that example. That is to say x minus 3 and x plus 1. And what this is asking me to do is to figure out where this is positive. So I know that I'm going to have x-intercepts at -3 and at +3 and at -1. So I'm going to do just a quick little sketch of this. I have an x-intercept at -1 and another one at +3. And I notice from this original equation that because a is positive, this parabola opens up, which means the vertex must be down there somewhere. And I'm just going to guess. It actually doesn't matter where the vertex is. If this is opening up, my parabola is going to look something like this. The question is asking on which intervals is the function positive? Well, we know it equals 0 at 3 and at -1. So my positive values are going to be above and above. And we've done this already before. -∞ to -1, that's going to be positive. And also 3 to positive infinity will give me a positive section of the graph. You should have this graph drawn. We will also I will write this for you just so we have it. This is also can be written as x is less than 1 or x is greater than 3. These are just interval notation versus inequality notation. All right, our last equation or problem is similar to ones that we did the other day. We're writing the equation of a parabola with these x-intercepts and that passes through this point. As soon as you know x-intercepts, that should trigger you to think that I want to write something in factored form. So I know that this part of my equation is going to be y equals, I don't know a, and then x plus 2, because it should be opposite of what this solution is, and x plus 1, because it needs to be opposite of that one. All right, now, just like we did the other day, to find my a value that I'm missing, I need to use the x and the y that I was given. This time we're going to have to plug those into a few different places. So y is 20. I don't know a. X is negative 3 in both of these situations. So negative 3 plus 2, negative 3 plus 1. When I work this out, this is going to give me a times negative 1 times negative 2. All right, or a times 2. And when I divide that out, I know that a is 10. So my final factored form, or answer, for this equation, is going to be y equals 10, x plus 2, and x plus 1.